Welcome back. I'm kicking off a new series on my channel that teaches you the basics of one of my favorite software tools called Drake. In this video, I'll show you how to install the Python version of Drake on your local machine, but first some background on Drake. So what is Drake? Drake is a C++/Python toolbox used for simulating dynamical systems and solving mathematical programs. It's a hybrid simulator, and it allows you to simulate models with both continuous and discrete time dynamics, such as walking robots. There's also a suite of tools designed for control engineers, such as AutoDiff, for linearizing dynamical systems around a trajectory and quickly creating LQR controllers. So the point of this series is to get you up to speed using Drake. So I've been using Drake for about 2 years now, and what I found when I was learning is there's not a lot of good tutorials that get you from zero kind of onto your feet to the point where you can actually read the documentation, read the source code, do the official tutorials, and get a lot out of it. It was a lot of kind of confusion and kind of an information overload. So I'm trying to mitigate that by putting together this dedicated tutorial series just to get you up to speed and show you kind of all the essentials of Drake without overwhelming you. So for an example of what you can do with Drake, take a look at this Acromonk robot. So this is a two-arm robot that can do monkey bars, and it was really cool when it was created in 2023. The entire project is in Drake. It's all open sourced, so you can learn how you can import the robot into Drake, how you can do trajectory optimization in order to design the path that it takes to go from one monkey bar to the next, and then design some sort of stabilizing controllers such as a finite horizon LQR. Okay, so I'm here on my Linux machine, and I'm going to show you quickly how to install Drake. So first thing, I just opened up VS Code, and we're going to clone my repository. So just navigate wherever you want on the command line to where you want to download it, and then I'm going to type git clone, and then we're going to steal this link from online. If you go back to the main page, you can go to code, and then you can just download this here. Paste that in, and boom. Now we can see that we have downloaded that folder. So if we go into there and we open up a new terminal with code dot, then we'll have this guy downloaded. Okay, so the next step is going to be to install your Python virtual environment. And to do that, make sure that you have the Python extension. So if you type Python, just make sure you have this guy downloaded. Then we can go Control-Shift-P, Python create environment, create a venv virtual environment, select your interpreter path, and then this guy is going to install a few things and get working. All right, so we've selected the environment. That's perfect. I'm going to open up a new terminal with Control tilde, and what I'd like to see is a .venv in parentheses over here. That tells me that the terminal is sourced. You can also type which pip, and you see that pip's not being selected. So this is no problem. If you just type source.venv/bin/activate, this will source the virtual environment. And now if we type which pip, you see pip comes up inside the virtual environment. Same with which Python. This is exactly what we want. In general, I always like to have virtual environments set up for my Python projects so that my dependencies for one project don't affect the dependencies for another. Perfect. Okay, so now we're just going to go ahead and do a pip install for Drake. This is going to download a bunch of different modules that Drake needs, such as matplotlib and numpy. So this only takes a couple of seconds, and then we'll be able to run some code. Okay, perfect. So I'm going to go back to the Explorer, and we're just going to go ahead and try one of these. So let's go to lesson 1, run this guy. And this is just simulating a double integrator that's being driven by a sinusoidal input. Here is the position versus time, or x. Here's its derivative. And last but not least, here is the sinusoidal input that we're passing in. So that guy looks good. Let's go ahead and do something a little bit harder. Let's go to lesson 4. And we'll run this guy. You'll see that we started a Meshcat session at a local host. So you can just click that. I already have it open. So I'll just go over here, open this guy, and you see we have a pendulum and I applied a swing up controller so that we can swing this guy up, and then once it gets close, it switches to an LQR to stabilize. That's all for the Linux installation. We'll get back with the Windows now. Okay, so for Windows users, the first thing I want to point out is that Drake is not officially supported by Windows, but we can still get around this using the Windows subsystem for Linux. So first we'll want to install that. So if you're on Windows 10 or 11, then you can just go to Windows PowerShell and run this guy as administrator. When this guy is open, we're going to want to run this first command, WSL install-d, then Ubuntu-24.04, and let this guy install. It might take a couple of minutes, but I'll come back when it's done. Okay, it's going to prompt you for a username and a password. Just make sure that you don't forget your password. And you see it set it up, and we're already inside of Linux. So that's perfect. So the first thing we want to do is do a sudo apt update. All right, next we'll do a sudo apt upgrade. You'll also want to run sudo apt install graphviz. You'll need that in order to visualize the results of matplotlib on Windows. Okay, perfect. So that's all we need to do here. So now we can go ahead and close PowerShell and we can open up Visual Studio Code. So let's do that now. Okay, so I have a new window open. The first thing I want to do is go over here and install the WSL extension. So this is by Microsoft. You're going to need this in order to actually access the Ubuntu system. Then you can go hit Control-Shift-P to open this command palette. Then WSL, connect to WSL distro in new network. Select Ubuntu 24. This will open up a new window. And this is actually, I don't know if you can tell right here, but in the bottom corner, this says Ubuntu 24.04. So we know that this is actually the WSL connection. So I'll full screen this. And what we're going to want to do is first go to some extensions. Make sure that you have Python installed. So I'll go ahead and install this. And then also get Jupyter installed. Perfect. So now that those guys are installed, I can go to my Explorer and let's clone my tutorials repository. So from GitHub, you can put the URL in, or you can just type it in. So logdog slash, these are all my public ones, slash Drake tutorials. Just click that. Now you want to just open up this repository, and you see that my whole repo has been cloned and we have things open, which is great. So now we need to actually install Drake. But first, what we want to do is set up a virtual environment. So because this is Python, we want to have a virtual environment to kind of encapsulate all of our packages so we don't have any sort of cross-contamination, sort of. So we'll go ahead and select Python, create environment, create a virtual environment. I'm using Python 3.12. So we'll get that guy set up. It'll take a couple of seconds. You see we've selected the appropriate environment. If you open a new terminal with Control tilde, you'll see that the virtual environment was sourced. If that wasn't the case, then what you want to do is run source venv/bin/activate and hit run. And that would automatically source the environment, but I don't really want to do that, so I'll just cancel on that. And now what we want to do is just type which pip, make sure that pip is inside the virtual environment, and then do pip install Drake. This will install all the dependencies, and it should just work once we get this guy installed. Perfect. Okay, so I'm going to open up lesson 1 solution, and I'm just going to naively run this. This probably won't work. So I'll run this, and you see that there's all these issues with plot.show. There's some issues using the Windows subsystem for Linux when it comes to making interactive GUI windows, but we can get around this using the Jupyter extension. So what you'll do is hit Control-Shift-P and go Jupyter, run current file in interactive window. And when you click that, of course, this is going to require the iKernel package, so we'll go ahead and install that. This one takes about a minute to install, which is not that bad. Okay, and then when that runs, you can actually see all the figures came up. So we'll get into this in the next video, what this is doing, but you can see we have a nice block diagram of our system where we have a controller, our plant, which is the double integrator, and then we're logging the values of the controller and the vector sync. You can see the position versus time graph, the velocity versus time, and also the control input U versus time. So that's great. We can go ahead and do something a little bit more complicated. If you go to lesson 4, we have a really, really cool solution here. So this is an inverted pendulum swing up controller by Mark Spong out of the 90s. This is a very famous example. So you can go ahead and run this file in the interactive window. We'll let this guy run. You'll see we have this mesh cat listening for connections. So I'm going to go ahead and open that in browser. And you can see our simulation. So this is our pendulum, and you can see it's swinging it up, and then it's going to switch to an LQR controller and stabilize at the top. So if you enjoyed this video, please be sure to leave a like button and subscribe, because we have a lot more Drake content to get through this year. So I'm really excited to continue this series, and I hope that you learned something new.